Okay, so today I want to talk about web workers and TypeScript, truly parallel web computation plus types. But wait, JavaScript/TypeScript isn't already parallel? Well, actually not. So JavaScript is asynchronous, but it's not parallel. JavaScript actually runs on a single thread in the browser. Async code is queued up for execution after any synchronous task is complete. Is this microphone volume okay? This is good, all right. And so what that means, if we look at this example here, so we grab just like the current time, and then we run a set timeout at 100 milliseconds. Inside the set timeout, we grab the time again, and we print out the difference between the two times. We just see how much time has elapsed. So with the set timeout of 100 milliseconds, you'd think it would print out 100, right? But if right after we call set timeout, synchronously, we call a big synchronous computation, and let's say it lasts 500 milliseconds, when this set timeout resolves and the console.log fires, it'll actually be 500 milliseconds in a clean environment with no other synchronous code getting in the way. Because JavaScript, it is just a single thread. Anytime you async anything, it gets put in this asynchronous queue and just lets all the other synchronous stuff complete, then gets popped back in. And the danger here is that means that long synchronous tasks can block the thread, and all of these asynchronous things that can happen are blocked from occurring. They have to wait until the synchronous thing is complete. And in the browser, the main browser thread, that includes really important things like laying out the page and painting the page, listening to any user interactions, and handling web responses, like if you've made an AJAX request. So essentially, like your page freezes up if you're doing like a big long for loop and crunching through your computation. A good side note is that CSS animations and transitions do not get blocked and are not blocking. They're on a separate compositor thread. So this is a reason to prefer CSS for animations over JavaScript. But regardless, enter the web worker. Web workers execute in parallel, truly parallel, on their own CPU threads. They exist in a new JavaScript realm, scope, context, whatever you want to call it. They have their own global object. They don't have access to the global window object. And then they operate by exchanging messages with their parent thread. Whoever spawned the worker can send messages back. That parent can listen, send messages to the worker. Workers can also spawn other workers and make web requests themselves. So you could have a worker off spawning child workers and making web requests, all in the background, all in a parallel thread. Here's a simple example of a worker just in JavaScript. So let's say this is running in our browser, this is our main file, and the worker, you just say new worker and give it the relative path to where the worker file lives. And then you, on this worker object, on this instance, you can add an event listener for the message event, and it will pass you this event object, which has all sorts of properties on it. The one that I'm going to focus on today is event.data. This is the payload for anything that you pass or receive from the worker. And then worker.postMessage, you can send an object up to the worker. And then within the worker itself, it has this self object. It's kind of like the window object, but in a worker. You can, again, very similar syntax, and then add an event listener for a message, read the data off of it, and again, very similar syntax. You can post a message. Hi, this is the worker. The limitations of web workers, they can't access anything DOM related, so you can't do any HTML stuff as CSS, SVG, or Canvas. They are also expensive to set up and tear down, and they have a pretty large memory footprint. They're really intended to have a small number of long-lived workers versus just like spawning and tearing down workers all over the place. You can do some things to optimize your worker usage. Window.navigator.hardware concurrency will tell you how many logical threads are available on the computer. And so that's really the optimum number of workers if you're trying to choose how many to run, because that's how many threads you have to work with. You want to probably share one worker among your processes versus having like 20 tiny workers have 4 big workers and have them share things. And then just in general, think about long-running workers versus creating destroying workers. A good question to ask is what percentage of your pages would use workers? So like here at ExtraHop, we do use workers for a lot of stuff, but a small number of our pages use them, so we do end up going through the create-destroy cost for most of our usages. Speaking of, what are workers good for? They are best for large computation tasks independent of rendering. And so an example I'm going to show you is our own live activity maps, a feature that we have here. It is a force layout. So this is a force simulation layout. It can take an arbitrary network, a connection of nodes and edges, and it runs a physics simulation on them. Oh no, Colin, how do I pause the protocol rotating? It is pause, okay, it's just updating. The physics simulation succeeds in laying these out in a semi-pleasing way for any topology that you throw at it, which is nice. But it's also very expensive. This physics simulation is an n-body problem. Each body in the physics simulation needs to know about every other body to measure the relative forces between all of them. And so the big O runtime of it is n squared. Each thing needs to check each other thing in order to compute it. And it's very expensive. So you can see, let's see if it happens again. In the bottom here, this green bar will run, and that is the layout being calculated. But we move the layout onto a worker thread so that it doesn't block the responsiveness of the page. So even if you do something like 500,000 workers, or 500,000 devices, it won't block the rest of the page while it's trying to crunch that. It will do its best. It will report on its progress while it's trying, and up to like 20 seconds or a minute later, it will lay everything out for you. Okay, that's enough of choking this page out here. So workers are good for these large computation tasks. We solved this live activity maps synchronous computation problem by splitting the computation apart from the rendering, moving the computation into a web worker. And now let's talk about TypeScript. This is our TypeScript meetup after all, and talk about how to type web workers. The first tricky part, immediately you run into a problem when using web workers with TypeScript, which is very frustrating. There is currently a conversation on GitHub, but what happens is TypeScript has the DOM library that it uses for all of the built-ins that you have while in the browser context. And then separately it has the web worker library that is all of the built-ins you have available in the web worker context. And those two conflict with each other. They have certain properties that are named the same but behave differently, or even different properties. But TypeScript compiler, while it's compiling your code, assumes that it's all running within a single context. All the code is available to all the other code. So one thing that they're working on is making these definitions more modular. Hopefully soon in the future, this will be solved. But for now, the current hack is to actually just cherry pick the exact definition of the worker scope, this dedicated global worker scope, and I just pulled it out of the type definitions file and made a copy of it. And then, so this is just a JavaScript worker. And then in worker.ts, I've stolen this dedicated worker global scope type here and just done like a self as unknown to kind of unset any conceived notions, and then as dedicated worker global scope. And then just use the scope. Now this is correctly typed, so if I do scope.add event listener, TypeScript will know what events are possible on it and what the objects passed to those events will look like. So that's typing the web worker context itself. Now you can operate within the web worker. And then what about messages to the worker? You can send these kind of arbitrary JSON objects to and from the web worker. And they type it as any. E.data is just any, could be anything. You can also hack the stolen definition to make it unknown. It's a little safer that way. You have to actually prove what the value is before you access it. But regardless, you are probably going to be sending some predictable set of messages to and from your workers. and you want to type each of those messages that you're going to send. And the recommendation in that case would be to use discriminated unions plus switch statements. So I'll show you what that looks like. So here, imagine this is our worker TS, and it's running a basic simulation. We import our simulation here. We can say it either exists or is undefined. And then we have 3 different messages that you could send to the worker. And we use this type is the discrimination on the union. So here you have the init message, and that'll come with a config object. You can have a run message, and that'll come with the data to run through the simulation, or a halt message. And then in the worker, you add an event listener. And if you say this message from e.data, instead of any, you unsafely declare it as a message to worker. You could be stricter here, but this is good enough. Because then if you do, oh, I'm sorry, this should be message.type right here. If you switch on the message.type, TypeScript will know in each of these cases if the type is init to expect that a config object also exists. And then you can do message.config. Oh no, it's going to be like this on every slide. If it's a run type, then you can do message.data, pass it to simulation.run. And if it's a halt, there's nothing else on the message object, but you can halt the simulation. So now we have a worker. It can create a new simulation with config on init. It can run the simulation with data, or it can halt it. And then in main.ts, we can also receive messages. So let's say the worker can send a progress message with a %done, or a complete message with the final positions of the data. And so in the worker, or in the main, it can add an event listener onto the worker and do a similar thing where it has a switch statement, it switches on message.type, and then can handle the progress message or the complete message. In the worker, we also want to be able to send messages to main. We weren't actually sending anything there. So we import that message from worker type. You want just like a general post message that takes that type. And then so anyone can pass blind objects to this post message, and it will put type safety on it right here. This is like your only point of failure. Because scope.postMessage, like it'll actually take anything. You can pass whatever you want to it. So this is your way to bottleneck yourself from throwing bad objects into your worker. So we make like an onProgress callback, passes a progress message, an onComplete callback, passes a complete message, and just add those as callbacks to our simulation.run. Let's just imagine simulation.run is expecting some callbacks to call. And then same for sending messages in main. You want your one bottleneck here because you're passing it to an any that's very permissive. So this function argument is where you're getting all of your type safety. And then all of these are calling your own custom post message with the type safety. So if you want to initialize your worker or run your worker, it's all type safe up until this point right here. Home stretch, that was all the TypeScript. Just got a couple loose ends now. Cleaning up your web workers. When you're done, you want to close the connection. If you call worker.terminate, it will halt the worker in the middle of whatever it's doing. So this assumes that you don't need any more updates from your worker, you don't care, you're just discarding it. Workers, I said that you can kind of pass any JSON objects to them. It's actually more complicated than that. They use the structured clone algorithm. So you can pass all primitive types, objects, arrays, also maps and sets, whole blobs, files, image data, date objects, regular expressions, which is far beyond what JSON can handle. It's just objects, arrays, and primitives. You still can't pass functions or errors or DOM nodes or anything with a prototype chain. So it's kind of like JSON Deluxe. It even preserves references. So if you have an array of objects and a map of objects, and they're both pointing, like all their children are pointing to the same child objects, and you mutate one through the map, the one that you access through the array will be that same one. You'll receive those mutations. Whereas in JSON, if you passed an array of objects and a JSON of the object of the same objects, it would become copies. They would get split on the other side. If you mutated one, you would see the mutations from the other. Yeah, question?
So if you pass those objects to the worker, is it by reference or by value?
So that's an interesting question. So within what you've passed, it'll be by reference, but between the worker and the main thread, it'll be by value. Those two stay in completely separate contexts. Yeah. You can do, okay, asterisk. Passing messages is expensive. Ideally, there is this thing called shared array buffers and atomics. It's a way to actually share a data structure between a web worker and the main thread so they could both access the same data structure. Unfortunately, the Spectre and Meltdown exploits put a stop to this. You were able to use these to get very accurate timing about the CPU, and something about that enables the Spectre exploit. I don't actually know the details. They're now reappearing behind browser flags, so there's hope that someday we can actually use them. Communication would be much faster if they're just using the shared structure and putting locks on it. But TBD, just don't worry about it yet, focus on messages. There are other types of workers out there. Everything I've been talking about is the dedicated workers, missing a D. They're the simplest. There are also shared workers, which are very similar, but you can share them between multiple tabs or windows or iframes. And there are service workers, which again are fairly similar in appearance, but they serve more as network layer proxies. And they're very good for caching or request batching, things where you want to intercept all of your network communication from a page and do things to it, both going out and coming into that page. Further reading. Coincidentally, Surma at Google has been posting about workers recently. Like while I was writing the slides, he's very useful for nailing down some of the finer details I've always wondered about. He has 3 articles. When should you be using web workers? His conclusion is always. Is post message slow? There's a lot of debate about structured clone algorithm versus JSON stringify and parse and the relative speeds of passing both of those. His conclusion is that past 100 kilobytes, they're both slow, and they're both pretty equally slow. There's no real advantage to JSON stringify. And then he also gives a bunch of good solutions for keeping messages small, like doing patches instead of full updates. Then his 3rd article is about React and Redux and comlink off main thread, and it's a way to move your entire Redux aspect of a React Redux application into a worker in a way where you can't even really tell it's in the worker with this comlink library. I want to try comlink. I don't really know anything about it, but it appears to wrap chosen functions and kind of proxy them. So you can still call them the same way that you were calling them, but they now live on a worker when they actually get executed. It looks almost disturbingly magical, but also useful. And then, a few days before today, a contrary piece arose in response to Surma, coming out with all these very optimistic articles. And it was titled, Should You Be Using Web Workers? Hint, probably not. He, in the article, identified himself as contrarian, like he was just trying to be devil's advocate on this one. But what he was pointing out was you should only really use web workers if you have big synchronous chunks of computation. If you have computation that can be broken up into asynchronous chunks and stretched out, or you just don't have these massive piles of computation like physics simulation, then you might not have to worry about web workers and you can keep living your life in a single thread, and it's fine. And that is everything. Any questions? Yes.
I've got 2 questions. So you mentioned about the expensive startup and teardown time. Would it be like reasonable to pool them, to have like a pool of web workers and then send work over to them?
Yeah, that would be ideal. So in the ideal scenario, let's see. In the ideal scenario, you do this window.navigator.hardware concurrency to figure out how many threads you have to work with, spawn that number of workers, and then use that pool to spread all your tasks out amongst.
And I don't think you got into how you send tasks, or if you did, I didn't actually see it. Did they just run like a specific JavaScript file, or can you send a Lambda to them, or?
So they do run as a JavaScript file. So you'll actually have like a worker TS file. Let's see. So like here in this example, this literally is just like two files, your main.ts and your worker TS. And then when you create your worker, you're just giving a path to that file, and it will run whatever's on it. So if you want to specialize worker, you can have two different files, and they just know all the things you've coded into them. But that is also the interesting thing about this comlink library, is that instead of having these dedicated worker files, you're just wrapping arbitrary pieces of your code base in this comlink, and it proxies them through to a worker somehow.
Oh, interesting.
Yeah, so that's more being able to pass a lambda.
Yeah, and because the last question I was going to ask you, I'm surprised I had 3, not 2. Do they have different optimization contexts? Like, you've got to parse the JS, it gets put into some intermediate form and then run through the optimizer, and I'm wondering whether that has to happen again per each worker thread.
That would be more, yeah, like in terms of if you're passing a lambda.
Yeah, like let's say you've got that worker.js file, and that shares like lib.js that's also used by your main, code.
Ooh, yes. So that's a problem that Webpack has right now, and this is something we're suffering at ExtraHop. When you import something into your web worker, it actually needs its whole own separate version of that in the bundle. There's like the web worker bundle and the main bundle. So those are two different files that get loaded up. So try to be very sparing with what you import into your web worker, because you could end up with like 2 full versions of Lodash, which is what happened to us for a while. So yeah, try to trim that down as much as possible.
Thank you.
Yeah. Any other questions? Yeah.
Do you know what browser support is like for on worker threads at this point?
I haven't checked in a while. No, can I use web workers? I love this website so much. Ooh, said that too soon. I cannot use this website.
It's because it's using web workers.
Or maybe it's not.
Yeah.
Or yeah, maybe it should be using web workers. Wow, this website is really crashing right now. Is it Chrome? Well, in conclusion, I'm not sure, and the whole internet is down.
I think it's pretty safe for the last 2 versions or whatever.
Oh,
Been around for a while.
right, we must have looked at some point before we started shipping with them.
Yeah.
So,
For a while, the thing that is not safe is shared web workers. They are not supported in, I forget if it's IE11 and Edge or just IE11.
it would be IE11 is the limiting factor.
So maybe you care, maybe you don't.
To us, we're like last 2 major versions of each major browser. So that, it definitely supports that. We checked at one point.
And do you know if it includes service workers? Support?
None of our customers.
I don't know.
I'm not sure.
I
Really, not IE for service.
think aside from that, they're pretty. I think most browsers support service worker. There's continued development. Service worker API is kind of changing. It's kind of early. Safari is kind of funny of service workers. If you're developing for just Chrome, it works pretty well. But otherwise, you'd be a little cautious of.
Okay, that's good to know. I'm still just a dedicated worker guy, so I'm free from all of this stress. Any other questions? All right, well, thank you very much. And on to Ian and a quick intro to Elm.